love my friends. Whenever my birthday came around, they would always surprise me with something new. They would cover my eyes with their hands so that I can see nothing. After that, they'd remove their hands, letting me see a flash of light and colors. Why is that?
When light from the sun hits these objects, they reflect it in straight lines. When this light enters our eyes, our brain recognizes it as objects, people, and places. Closing our eyes prevents light from entering it. Thus, we can only see darkness. That brings us to the question, what is light anyway?
Is light a wave or a particle? This has been a long debate for centuries by the greatest minds in science. Isaac Newton first proposed that light was a particle. He believed that these were made up of small discrete particles called corpuscles. This was helpful in discovering some properties of light, but not most of them.
Then, this idea was disproved when a famous Dutch physicist named Thomas Young conducted the famous double-slit experiment. If light behaved like a particle, then as light enters the two narrow slits, we'll be able to see two lines since particles travel on a straight line. But that is not what happened. I'll demonstrate. Once this laser goes through the two narrow slits, it will create an interference pattern. Now these patterns are formed if two plane waves of the same frequency intersect at an angle. Just like when we create ripples of waves in a pond. So, light is a wave, right? Well, this is true until the photoelectric effect was discovered.
I know you're a bit confused, and so was Albert Einstein, which led him to research it and subsequently formulate, in 1905, a new corpuscular theory of light. The photoelectric effect is a phenomena where electrically charged particles are released from or within a material when it absorbs electromagnetic radiation, in which each particle of light or photon contains a fixed amount of energy, or quantum, that depends on the light's frequency. This explained photoelectric effect because an electron is ejected when struck by a singular photon with sufficient energy. Higher frequency meant higher energy photons, and lower frequency meant low energy photons.
And so, to finally answer the question, is light a particle or a wave? Well, sometimes it can be described as a particle,
And sometimes it can be described as a wave.
and
Sometimes it's either.
Now, this revelation opened the scientific community into a whole new physics theory called
Quantum mechanics.